Okay, so number 4. So they're giving us a piece of a graph here. And they're asking us, they're saying, what is the lowest or least possible degree of the polynomial graphed above? What's the lowest or least possible degree of this polynomial graphed above? Well, that's interesting. Again, I'm going to do it by way of comparison because math is just a bunch of patterns. So let's think about an x squared graph. What does an x squared graph look like? Well, it's a U shape, either up or down. You know that. Okay. And notice an x squared graph has what we call one turning point. See how that's a turning point where the graph was going down and now it's going up. Like if you're on a roller coaster, that'd be going down, 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 down. Now you're going up, 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 right? So an x squared graph has one turning point. So the power, notice, the power equals the number of TP, toilet paper, no, turning points, plus 1. Do you see that pattern there? Right? The power is the number of turning points plus 1. Right? If you have one turning point right there, then your power is 2. So if you have 1, 2, 3, 4, so 4 turning points. So the power must equal the number of turning points plus 1, like we just saw right here. So the power for this graph must be 4 plus 1 must be 5. That's the lowest it could be. That's the lowest power it could be when you see all those turning points. It's the number of turning points, add 1. That's the, now why do we say that's the lowest? Well, it could be higher. It could be even higher. Like you can have an x to the 4th graph that actually kind of looks like a U shape also, and only has one turning point. So so really it could be higher. The lowest it could be is 1 more than the turning point, but it could go even higher, as that example showed. So it's the number of turning points, add 1. That's the lowest possible power, is the number of turning points, add 1. That's the lowest possible power. There we go.